Okay, I've been asked to do this particular problem and started it out, so we'll do the velocity and the acceleration of both. First thing to realize is that this is a 2 degree of freedom system. If you look down from the top, you have this pipe and the bent pipe, and it's rotating around the z-axis. And then on the pipe there's a collar which is being moved out from point B to point A. Now, to be perfectly honest, what I would do is I would use either r theta coordinates or tangent normal. Actually, r theta is probably the better one. And I would do it using the chapter 12 material. But because it's in chapter 16 and we're using the special points formulation, I'm going to go ahead and demonstrate how to do that. So essentially there are two special points in this problem. Point B is special because it is essentially fixed to the ground. It's not going anywhere, so I know the velocity of it. And the other point is point C, which is touching the collar C, and it's also touching the AB pipe. So those 2 points are special. They're not really on a body together, but they share a body, which is that pipe. And since there are two of them, the number of equations I'm going to write is 2 minus 1, or one equation. So what I've done here is I've written that equation right here. This is one velocity equation between the two special points between C and B. Makes no difference whether you start with C or B. Either one would be fine. So here I write velocity of C equals the velocity of B. By the way, since it is 2 degrees of freedom, that's why there are two things that are given. There's a velocity and acceleration there, and there's a velocity and acceleration here. So there's two single dot terms and two double dot terms, and that's why I know it's no free body diagram, because I can find all velocities and accelerations. Okay, back to where we were going. So you have this one equation, which is the velocity between C and B, and the term that's kind of unique in this case is this relative term right here. So the other terms you're probably familiar with. Velocity of C equals velocity of B plus omega cross R. The omega is the omega of the body they share, which is in this case the pipe. So it'll be omega BA cross R. And here, this was done in a earlier time. This is going to go from B to C. So I kind of switched the notation that I've used from one semester to another. So this goes from B to C. And so if you plug in, or you look at how I plugged in here, velocity of B is obviously right here. It's not going anywhere. It's basically fixed to the ground, so it's equal to 0, which is what I have written here. And then the omega is, if you look at the figure, the omega is given as 6, and if you look closely at the arrowhead, it's going in the counterclockwise direction if you look from the z-axis, so that's going to be 6k, which is what I plugged in right here, positive 6k, cross the r goes from B to C, so it's going to go from here straight out this way, which is a distance of 0.5, and it's in the j direction right there. So that's why I put in 0.5j for this. Now the rel term is the new part right here. This is the rel term. So to get that, what you would do is you pretend like you're standing here on the pipe. Now you have to use your imagination, but if you were standing on the pipe, you'd look over at B. It doesn't look like B's going anywhere because it's at the end of the pipe. C doesn't look like it's doing much, but it looks like it's getting 3 meters, or has a speed 3 meters per second, and is moving away from your foot right here, right? So what it looks like to you that the collar is doing is moving a distance, or a speed of 3, and it looks like it's going out this direction in the y direction. That's what it looks like to you if you were standing on the pipe. you don't see that it's actually spinning and all that. You only see that it's sliding out the pipe. So that's what I put in here. Positive 3 in the J direction. So now if you just do the cross product, then you'll take 6 times 0.5, you get 3. K cross J is a negative I, so that's why it's a negative and it's an I. And then you bring down the 3. So what's the velocity of C? It's given right there. Now they also want the acceleration at this instant. So what I'm going to do is, now that I've done the velocity equations, I'm simply going to mimic the velocity equations and write the acceleration. So I'm going to write the acceleration of C equals the acceleration of B plus, instead of being omega cross r, it's now going to be alpha, the angular acceleration of the body that they happen to share, cross r. It's going to be exactly the same r as it was before. So I'm going to use this notation. It's going to go from B to A. And then in two-dimensional problems, it's always omega squared r. It's the same r that we used before, so it's going to go from B to A. In 3 dimensions, it'll be omega cross parentheses omega cross r. So in 3D, you got to do the whole thing. But in 2D, all of this is going to simplify. It always will simplify in 2D to omega squared minus r. Okay, plus the official equation always has plus 2 omega cross v rel plus a rel. That's the formula that will come out of the book. So now I'm just going to plug in chug. So the acceleration of C, acceleration of B, well, B is in permanent contact with the ground, so it has the same acceleration as the ground, so that's 0. Alpha is given. In this case it's 1.5, and it's also in the positive K direction, so we'll plug that in. This is going to be a 1.5 K cross, it's the same r that it was before, so I look back up here and it's this guy right here, 0.5 J minus omega. Well, I found the, or excuse me, in this case I was told the omega, but if you didn't know the omega, that's why you would solve the velocity equations and you would be able to calculate it. But in this case it's given. It was 6. So I'm going to plug in 6 squared is 36. The r, well, I've got the r. I'm just going to copy it down, 0.5 J. If you're neat when you're doing these problems, you can just kind of look back and not really have to think about it too much. Plus omega. Omega is equal to 6K cross v rel. The v rel was right here. Right, so it's cross 3J plus a rel. So now to get the a rel, what you do is you pretend like you're standing on the pipe, just like before. You look at the collar and you ask yourself, what does it look like it's doing? Well, it looks to me like it is moving out the pipe with an acceleration of 0.5. So that's the a rel term. So the a rel term is 0.5. In what direction? Well, it looks like it's going out the pipe, J. So in this particular case, the only thing, everything on the right hand side is a number. So let's just do the cross products and we'll have it. The acceleration of C equals 1/2 times 1.5 is 0.75. K cross J is a minus I. And then I have minus half of 36, which is 18. So that would be minus 18 J. And then for the next one, I have 6 times 3 is 18. K cross J is a minus I. And then I have the v rel term, which is plus 0.5 J. Adding them all up, acceleration of C equals, let's pull all the i's together. That looks like it's a negative 18.75 I. Let's pull all the j's together. It looks like it's about 17.5 negative 0.5 j. So there's your acceleration. And of course, most people don't have a feeling for whether or not that's right, so there's not much I can say about whether or not I've done it correctly. But anyway, so there's the solution to that one. I'll post it and then do the next one that you'd asked for.